Hello viewers, in my last lecture I had described the structure of nucleotides and their nomenclature. Let us first recapitulate some important features of nucleotides and some more examples of their naming. You know, a single nucleotide is a subunit made from 3 different components linked via condensation reactions. The components include a phosphate group, a pentose sugar which can either be deoxyribose in DNA or ribose in RNA, and a nitrogenous base which may be adenine, thymine, guanine, cytosine or uracil. On your screens, now I have shared with you the general structure of a nucleotide, and what we find that we have a sugar, that is, which is indicated by S here. This is the general structure. It is attached to a base which is cytosine in this case, and it is attached at C1 carbon, whereas at the C5 carbon we have a phosphate group. So this is the general representation, that we will be having a base which will be attached at C1, and then we will be having a phosphate group which will be attached at C5 of the sugar. Now this sugar can be a deoxyribose sugar as in case of DNA, or a ribose sugar in case of RNA. Here I have again clarified this further, and what we find here is that we have a base and the sugar here is deoxyribose sugar. Why is it deoxyribose sugar? Because in ribose sugar, please remember, we have a OH group here, whereas in this case an oxygen has been removed, and since oxygen is removed, this is deoxyribose sugar, and we have a phosphate group at the 5th carbon. So this is the general structure of a nucleotide, and what we find is that this is formed by condensation reactions. Here I would further like to differentiate between a nucleoside and a nucleotide. When we talk of a nucleoside, we have a base which in this case has been taken as adenine, and the sugar here is the pentose sugar, and this is again a deoxyribose sugar, because you can see that we have hydrogen here, we do not have an OH group here, and the phosphate group. So when we are, and a phosphate group is attached here. So what you have to remember is that when we are talking of nucleoside, nucleoside is made up of a sugar molecule, a pentose sugar, attached to a base at C1 carbon. And when this nucleoside reacts with a phosphate group, and it undergoes esterification reaction here, and we have a ester bond here at this place, this is known as nucleotide. So what is a nucleotide? We can say nucleotide is nucleoside plus phosphate group is the nucleotide. You have to remember this, because when we will discuss the nomenclature, that is of nucleosides and nucleotides, I would like to recapitulate this also briefly. We will find that we are naming nucleotides as derivatives of nucleosides, because what are nucleotides? Nucleotides are considered to be formed from nucleosides when an esterification reaction takes place at C5 carbon. So first let us see how are we going to name nucleosides, and then we will go on to nucleotides. So if we are taking an example of ribonucleoside, you have to remember, in ribonucleoside, it is the sugar is always going to be ribose, and in this case example I have taken that the base is an adenine. So how are we going to name this? It will become adenine nucleoside if we are naming it as the full name. Now if we write the common name of this, please remember, ine will be replaced by ocene. So when we replace ine with ocene, the name of the ribonucleoside, this ribonucleoside will be adenosine, and this adenosine we normally use mostly. The next, if the sugar we've changed, that is, instead of taking ribose, the sugar is 2'-deoxyribose. So when it is 2-deoxyribose, what you have, and the base is the same, adenine. So what would be the name of the nucleoside here? It will become deoxyribonucleoside. And the common name, in common name, we will exclude ribonucleoside, we will just write it as deoxyadenosine. So what you have to remember, when it is a nucleoside of ribose and the base is adenine, we will write it as adenosine. And when the sugar is deoxyribose sugar and the base is adenine, we will write it as deoxyadenosine. So for ribose, we are just writing it as adenosine, and we will specify for deoxy, if the sugar is deoxyribose, that is, it is present in DNA, this nucleoside. So we will say the name is deoxyadenosine, and the abbreviation will be ADR. With small d, we are indicating that the sugar here is deoxyribose. So here again, I've shared with you the picture of a nucleoside in which we have a adenosine as a base, and you know this is a purine base, and then here we have a sugar molecule which is a pentose sugar. If it is OH here, that means it is ribose, and if it is H here, it is deoxyribose. So if the sugar is ribose, this will be named as adenosine, and if the sugar is deoxyribose, it will be named as deoxyadenosine. So that means, so this is how we will name nucleosides. Now we know what is a nucleotide. This we've already done. So nucleotide is a nucleoside that forms a phosphate ester group with OH group present at the C5' of ribose or deoxyribose. So now since we are adding a phosphate group to it, how are we going to name nucleotides? We are simply going to name them by using the name of nucleoside followed by 5-monophosphate. So that means if it is a nucleotide of, say, adenine, the name will become adenosine, which is the name of the nucleoside 5'-monophosphate. So here I have tabulated this for you, and I'll just take one or two examples to illustrate what we mean. That is, if the sugar is ribose and the base is adenine, so the nucleoside will become adenosine, and the nucleotide would be adenosine 5'-monophosphate, abbreviation for which will be AMP. And these are the abbreviations which we may use in future also in this lecture. So what you have to remember is that when we are talking of AMP, we are talking of adenosine 5-monophosphate, and in this case the sugar present is ribose. So if I take another example, which I would like to take of a pyrimidine. So in this case the base is cytosine. So what you have to remember is that when we have cytosine, we will convert ene into dine. So this will become, cytosine is the base, so the nucleoside will be cytidine, which is abbreviated as C, and again the nucleotide would be cytidine 5-monophosphate, which is indicated as CMP. Now supposing we are talking of DNA, we've changed the sugar from ribose to deoxyribose. So again, if we look into the example, just taking one example, we have adenine, so the sugar here is deoxyribose, so nucleoside would be deoxyadenosine, and the nucleotide would be deoxyadenosine 5-monophosphate. So what we've done here is, in RNA we are taking this as adenosine 5-monophosphate, whereas in DNA this would become deoxyadenosine 5-monophosphate. Similarly for cytosine, this would be deoxycytidine, and that is the nucleoside, and the nucleotide would be deoxycytidine 5-monophosphate. So this is how we will do the systematic naming of nucleosides and nucleotides. But you have to remember that the generic names or the common names of nucleotides are more popular and they are normally used because they are simple. So if we are now, as I'll repeat again, nucleotide is nucleoside phosphate. So how do we name them? We will name them by adding ylate to the nitrogenous base. So if you remember, the common name for nucleoside was adenosine if the base was adenine. So in this case, the nucleotide would be named as adenylate. So what we've done here is we've changed the ine into ylate. Similarly, if the base is cytosine and the sugar is, say, deoxy sugar, that is deoxyribose sugar, then we will name it as deoxycytidine, that would be the nucleoside, and the nucleotide would be deoxycytidylate. So if you look into more examples of this, I have taken both the examples for RNA and DNA. Now here we are just going to do the naming of the nucleosides and nucleotides. So if adenine is the base here, the nucleoside will be adenosine and nucleotide will be adenylate. Similarly, for DNA, what you have to remember, everything will be the same. Only what we are adding is we are adding deoxy. So the nucleoside will become deoxyadenosine and nucleotide would be deoxyadenylate. So similarly, guanine. Please remember, for guanine, it will become, nucleoside will be guanosine and nucleotide for RNA would be guanylate. Similarly, the nucleoside for DNA, we will just add the word deoxy. This will become deoxyguanosine and deoxyguanylate. Now we know for cytosine, which is again present both in DNA and RNA, the nucleoside will be cytidine and nucleotide will be named as cytidylate. For DNA, we will add the word deoxy to the name of the nucleoside, that is, it will become deoxycytidine and nucleotide would be deoxycytidylate. Now you have to remember, thymine is present only in DNA. Since thymine is present only in DNA, we'll just add the name of deoxy and the name will become, for thymine in DNA, since the sugar is deoxy, it will be deoxythymidine, that is the nucleoside, and the nucleotide will be deoxythymidylate. And when we talk of uracil, you have to remember, in uracil, in RNA, we have uracil in place of thymine. So in this case, the nucleoside will be uridine and nucleotide would be uridylate. So till now what I have done, I have quickly revised with you the systematic names and the generic names of nucleosides and nucleotides. So now what you have to remember, that when we are drawing the structure of DNA or RNA, you simply cannot write the full name. So there we will be using abbreviation to show where the bonds are. So for that we will be using the abbreviations, that is the symbols. So nucleotide units of RNA are usually symbolized as A, G, U and C, that is adenine, guanine, uracil and cytosine. They can also exist, please remember, these nucleotides can also exist in a free form, and when they exist in the free form, they are commonly abbreviated as AMP, that is adenosine, monophosphate, guanine monophosphate, uridine monophosphate, and cytidine monophosphate. Now, when we are talking of nucleotides of DNA, the symbols that we usually use there are A, G, T, and C, as we've been doing for RNA, but sometimes small d A, small d G, small d T, and small d C is also used, because this is indicating that these are, in these the sugar present is deoxyribose sugar. Then again, please remember, when we talk their existence in free forms, they are deoxyribonucleotides are commonly abbreviated as DAMP, where D is again indicating the sugar here is deoxyribose, and it will become DAMP, DGMP, CTMP, and DCMP, depending on the base which is present in it. And MP means it is monophosphate, that is one phosphate group is present there. So I have discussed the naming of the nucleotides present in DNA. But now the question arises that do all nucleotides form nucleic acids, that is polynucleotides, DNA or RNA, or do they exist freely also? So you have to remember that there is a category of nucleotides which occur freely and have other roles, and they play very important roles. So you have to keep in mind that we have these nucleotides which do not occur in polynucleotides, DNA or RNA. They are known as non-nucleic acid nucleotides, and this is what we are going to discuss in today's lecture and the upcoming lectures. So when we talk of nucleotides, we know that there are many nucleotides which will form RNA, like AMP, CMP, GMP, and UMP, as I have just told you few minutes back. And in DNA we have DAMP, small d CMP, small d GMP, and small g TMP. But what you have to remember is there are many other nucleotides that do not form polynucleotides, DNA or RNA, but they are very important in metabolism of cells. And the examples of these non-nucleic acid nucleotides are adenosine triphosphate, which is abbreviated as ATP. Then we have guanosine triphosphate, which is abbreviated as GTP. Then we have cyclic adenosine monophosphate, and in this case to the abbreviation we will write small c, which indicates that it is cyclic structure. Then we have nicotinamide adenine dinucleotide, which is NAD. The other ones are nicotinamide adenine dinucleotide phosphate. Then we have ferredoxin adenine dinucleotide, that is abbreviated as FAD. Then we have ferredoxin adenine mononucleotide, FMN, and then we have coenzyme A. So when we are discussing these, we can either use their full name, that is when we are writing NADP, you have to keep in mind that NADP is referring to nicotinamide adenine dinucleotide phosphate, and when we are referring to NAD, it indicates that we are talking of nicotinamide adenine dinucleotide. So this is what we are going to discuss in great details. But before looking into the functions of these non-nucleic acid nucleotides, let us see another way in which we can do the numbering and the naming of these freely occurring nucleotides. So what you have to remember is that we can name them on the basis of the phosphate groups which are present there. So if the phosphate group in these nucleotides will determine what is the name that we are going to give to a particular nucleotide. If there is only one phosphate, we will name it as monophosphate. So supposing, let us presume here that the base here was adenine, or the nucleoside here was adenosine. So if the base here was adenosine, this would be named as adenosine monophosphate. So this is indicating that the phosphate group is at the, there is only one phosphate group and it is attached to the C5 of the ribose sugar. So when we talk of nucleoside monophosphate, so what you have to remember is that the hydroxyl group of adenosine is esterified with the phosphate group to form two products. One is 5' or the other one is 3' monophosphates. What does this indicate? 5' or 5' or 3'? It indicates that the phosphate group will esterify at the 5th position or at the 3rd position. So if we look into the structure of AMP, what do we find here? That this is ribose sugar here, and the phosphate group is, the phosphoric acid is undergoing esterification reaction with the OH on the 5th carbon, resulting into AMP, that is adenosine monophosphate. Now, so for example, now we've taken here, we've taken an example, the second example, what we find in second example, that in this case the esterification has taken place at the 3rd OH, the OH at the 3' carbon. So this is your 1st carbon, 2nd carbon and 3rd carbon, and when this happens we are getting a different nucleotide which is adenosine 3' monophosphate. So this was named as adenosine monophosphate because the phosphate group which was present there, that was only one. Now if supposing there are two phosphate groups in a nucleoside, we will name it as nucleoside diphosphate. And how does this happen? In this case, a second molecule of phosphoric acid will react with the phosphate group which is already present in the nucleotide. That is with that phosphate group which is attached to the ribose sugar. So and then we will get a diphosphate, and this will be named as adenosine diphosphate here, because here we've got a bond here. So if you look into the structure or how it is being formed, so this was your monophosphate, adenosine monophosphate, and this phosphate group reacted with the second molecule of phosphoric acid, and please remember this is an anhydride bond, and what we get here is a adenosine diphosphate. That is 5', 5', which is indicating that both the phosphate groups are attached to the carbon atom which is at the 5th position, and we get ADP. Similarly, what we find that we can even generate a triphosphate. What will happen when we are making a triphosphate? The 3rd phosphate group will be attached to the 2nd phosphate group which is attached to the nucleoside diphosphate, and in this case we will get a nucleoside triphosphate which would be ATP. So here you can see the structure of a nucleoside triphosphate where the phosphate group has attached to a diphosphate. So here you can see the structure of adenosine triphosphate. This phosphate group has undergone a reaction with adenosine 5 ADP or with diphosphate, and when it undergoes this reaction we get another anhydride bond and we get a triphosphate. So on the basis of number of phosphate groups present in a nucleotide, nucleotide, we can also name it as ADP, AMP, ADP and ATP. For this lecture, I had discussed the books by Bruker, Nelson and Cox, Pierce, Klug et al. And Garrett et al. In my next lecture, now I shall be discussing the roles of these nucleotides. Thank you.